Section 5.5 Inverse trigonometric functions. So, like before, we have seen some functions which can have inverse. So, some our trig functions, we will see that we can have inverse trig function. But before we go into inverse trig function, we would like to take a peek into 7.4 section, which is about solving trigonometric equations. So we start with the solving basic trigonometric equations, or very simple basic trigonometric equation, and then we build to solve the complex or little bit difficult trig equation. Now here I will only discuss the solution of simple these equations, the basic equation. So for example, we have this equation over here, sine of t is equal to 1/2. So what does that mean? It means we are looking for a number t, a real number t, such that when we take the sine of that real number, we get 1/2. Now if you recall, there are a bunch of such numbers, actually infinitely many such numbers, and because of the periodicity of the function, and because of when we move on the circle, we come back to the same point. So for example, if we are looking for, for sine of t is equal to 1/2, and if we recall, pi or sine of pi over 6 is 1/2. So it means one value for the t could be pi over 6. Pi over 6 is somewhere here. But now note that if I instead start here, go around the whole circle, unit circle, and then move pi over 6. So what is the t value, or what is the value of the real number? It will be pi over 6 plus 2 pi, which means 13 pi over 6. So this is a different number, real number, but it is taking sine of this number, we get 1/2. And if you can make two complete circles and plus pi over 6, which will be pi over 6 plus 4 pi, we get 17 pi over, actually 24 plus 6, 4 are 24 plus 2, so this is 25 pi over 6, and so on. So if you remember, the sine function is positive in the first and the second quadrant. So there is another p value, which is just a reflection of this pi over 6 about the y-axis, and it lands us here. And what is the value of this t here? If you recall, this is 5 pi over 6. So we see that in our unit circle, if we move around, we get two real numbers which are going to give us solution of this equation. These two real numbers, which are the solution on the unit circle in one rotation, which means in the interval 0 to 2 pi, with 0 included and 2 pi not included, these solutions are called primary solutions. Now we build up the general solution on the like this, which I was mentioning here. So we have pi over 6 plus 2 pi into k. What is k? K is called integer multiple. So we are going to multiply 2 pi by integers, and we will get our new different solutions. Yeah, so and then we mentioned that k will take on these values. K can take on these values. Now, if the question asks you to give the primary solutions, you are supposed to give only these two values as your solutions. If the question asks you to write the general solution, this is the form you will write. Actually, this can be simplified and written. You can write this as pi over 6 plus 2k pi or 2 pi k as you wish. 2 pi k, and this can be written as 5 pi over 6 plus 2 pi k or 2k pi, and k is say 0 plus minus 1 plus minus 2 plus minus 3 and so on. Okay, let's look at few more examples here. So next is sine of x is negative square root of 2 over 2. Now the sine of x has a negative value. So when does that happen, or where will the in which quadrant will the terminal point be for x? In the third and the fourth quadrant, because sine is negative in the third and the fourth quadrant. So what value of t will give us this? So if you recall, square root of 2 over 2 is associated with the real number pi over 4. So pi over 4 means this is pi over 4. And remember, we find multiples of pi over 4 by dividing this unit circle into 8 sections. And I like doing this. If you don't draw the unit circle, you can directly see what x will be equal to. You may do that, but I think it's easier to look at this way. So if you recall, this is 0, this is pi over 4, this will be 2 pi over 4 or pi over 2. So why do I say 2 pi over 4? That helps me count the pi over 4, how there are. So this is 3 pi over 4, this will be 4 pi over 4, which is the same as pi. This will be 5 pi over 4, and this will be 6 pi over 4, which is the same as 3 pi over 2. And this last one here is going to be, so this was that one, and now we have the 7 pi over 4. So sine of pi over 4 is square root of 2 over 2. But we are in the third and the fourth quadrant, so our pi over 4, our multiple of pi over 4, that will be our primary solution. One of the primary solution will be the let me erase this one. So the primary solution will be this value, this t value, and this t value. So we have primary solutions. Right, x equals 5 pi 4 or x equals 7 pi over 4. Okay. These are primary solutions. What about the general solution? So we will just add 2k pi to each of them. So x is equal to 5 pi over 4 plus 2k pi, and the other one will be x equals 7 pi over 4 plus 2k pi, and k is going from can have values 0 plus minus 1 plus minus 2 plus minus 3 and so on. Okay, looking at the next example, this is sine of x is equal to 0. Now sine of x is equal to 0. When does that happen? If I look at my unit circle, so I know that it will be 0 over here and it will be 0 over here. So in the unit circle, in one complete revolution, we will have the value 0 and pi. So we say the primary solutions 0 and pi. X is equal to 0 and x is equal to pi. These are our primary solutions because they are in our one rotation. What about the general solutions? So general solutions, so as before, we can write x is equal to 0 plus 2 pi or 2k pi or just 2k pi. And the other one, pi plus 2k pi. So this one will give us x equal to 2 pi plus 2k pi. Okay, so these, and k goes from k is 0 plus minus 1 plus minus 2 and so on. Now these, it's okay if you leave them like this, but as you know, we can actually simplify this, because what is going to happen that it will be 0, the sign x will be 0, x at sign will be 0 at 0, pi, 3 pi, 4 pi, 5 pi, and so on. So we can say that x is equal to, this is the general solution, x is equal to k pi. Okay. So these two equations can be simplified into or condensed into one equation. Okay. Let's take a couple of more examples. X is cosine of x is equal to square root of 3 over 2. So which real number has its cosine equal to square root of 3 over 2? So see, if that is why I have mentioned that we must memorize these values. Now thinking backwards becomes easy. So if you recall, sine of pi over 6 is 1/2, and sine of pi over 3 is square root of 3 over 2, and cosine of pi over 6 is square root of 3 over 2, and cosine of pi over 6 cosine of pi over 3 is 1/2. So what are we looking at? We are looking at this situation. So we see that cosine is, now the other thing we have to think about is, when is cosine positive? So one value of t we got here, pi over 3. Is pi over 3 or pi over 6? It is pi over 6. So we have the value pi over 6. What will be the next value? So the pi over 6 is over here. If you recall now, the sign is positive in first and second quadrant, whereas cosine is positive in first and fourth quadrant. So the other t value will be here, just so that the point is a reflection of the point which is represented by pi over 4 about the x-axis. So this is a reflection. So the coordinate, what is the t value over here? It is 11 pi over 6. Well, you might notice that this is also the same as negative pi over 6. But remember, negative pi over 6 does not belong to the interval 0 to 2 pi. So you cannot take your primary solution to be. Now, negative pi over 6, by the way, is one of the solution of this equation. And you can find it by plugging in the proper k value in the general solution. But for primary solutions, the values will be x is equal to pi over 6 and x is equal to 11 pi over 6. So the general solution will be pi over 6 plus 2k pi, and then x equals 11 pi over 6 plus 2k pi. What? So you notice that the solution of cosine of x when square root of 3 over 2, or when cosine is a positive, cosine of x is equal to a positive number, the two t values that you get are, one is in quadrant 1 and the other is in quadrant 4. What if you have the cosine of x equal to a negative value? Here we have the negative value. When is cosine negative? It is negative in the first quadrant, in the second quadrant, and in the third quadrant. So one of the values will be in the second quadrant, and then the other will be in the third quadrant. So what is the value? So cosine equal of x is equal to 1/2. So what real number has its cosine 1/2? We just saw a few minutes ago that x will be equal to pi over, well, cosine of 1/2 is related to pi over 3. So if pi over 3 has cosine of pi over 3 is 1/2, but we have cosine of x is negative 1/2. So it means it is the multiple of pi over 3 which is lives here, and the multiple of pi over 3 which lives in the third quadrant. So what are those multiples? So it means we are dividing our unit circle into 6 sections. So 1 pi over 3, 2 pi over 3, 3 pi over 3, which is the same thing as pi, which it should be. Then we have 4 pi over 3, then we have 5 pi over 3, and then 6 pi over 3, which is 2 pi, but that is not included in our interval. So x is equal to 2 pi over 3 or x is equal to 4 pi over 3. So these will be the primary solutions. Now what about the general solution? So the general solution will be 2 pi over 3 plus 2k pi. So x will be equal to 2 pi over 3 plus 2k pi, and the other one will be x is equal to 4 pi over 3 plus 2k pi, and where k is equal to 0, plus minus 1, plus minus 2, and so on. So this is how we can find the solutions of cosine x equal to a number or sine x equal to a number. What about tangent? We can have an equation with tangent. We can even have it with secant and cosecant and cotangent, but if we can know how to do these ones, the other ones won't be that hard. So tangent of x equal to square root of 3. So now we have to think about the real number x, whose tangent is equal to square root of 3. So if you have that table in front of you, so you know the 5 over 6, 5 over 2, 5 over 3, 5 over 4, and then 5 over 3, and then I had 5 over 2. So if you sine or cosine of, even if you remember the sine of 5 over 6 is 1 half, cosine of 5 over 6 is square root of 3 over 2. Then we have sine of 5 over 4 is square root 2 over 2. Cosine of 2 over 2, 5 over 3. Sine is square root of 3 over 2. Cosine is 1 half. So remember, tangent is sine over cosine. So if you notice, because we have square root of 3 in here, it means it could be either this real number or this real number. So we have to just now check which one is it. Remember, the tangent is sine over cosine. So if I do this divided by this number, so I have 1 half divided by square root of 3 over 2, which means 1 half times 2 over square root of 3. So I will end up getting 1 over square root of 3, which is not square root of 3, which means it is not pi over 6, which tells us that it's going to be pi over 3. So the pi over 3 means this value. So we have only, I have drawn only one line here. We now, where is, in which quadrant is tangent positive? Because we have tangent of x is equal to square root of 3, which means tangent has a positive value. So tangent is positive in first quadrant and in third quadrant. So the other t value will be in the third quadrant. And what is this value? So this will be pi over 3. This is 4 pi over 3. Remember, in the third quadrant, the multiple of pi over 3 is 4. So now we will write, we will say a primary solution. X equals pi over 3. Actually, we can just leave it here, but if you want, we can also write 4 pi over 3. Now in this case, we will not add 2k pi for the general solution. Why? Because if we call from section 3.5.3.5.4 that the period of tangent is pi, not 2 pi. So if I write like this, pi over 3 plus k pi, and here x is equal to 4 pi over 3 plus k pi. So these two can actually be these two solutions. So let's see, for example, when I have k is equal to 1 here. When k is 1, what is my x? X will be equal to pi over 3 plus pi, which is 4 pi over 3, which is the value we have on this other piece. K is equal to 0. So which means values are overlapping here. max almost every value in this piece is contained in that piece, and the same thing goes. So we can just do one, we can discard one of them and keep the first one. Okay, the last example. So the tangent of x is equal to -1. So now our tangent is -1. So what do we, what should we be looking for? What is the angle, or what is the real number t such that tangent of t is equal to 1? That's where you should start looking. So when is the tangent equal to 1? If you recall, that is 1, tangent of x is equal to 1 when x is pi over 4. So pi over 4 is our, base where we start, pi over 4, and then this will be 3 pi over 4, this will be 5 pi over 4, and this is 7 pi over 4. Now, and since tangent is negative, and it is negative in the second and the fourth quadrant, so our primary solution will be 3x is equal to 3 pi over 4 and x is equal to 7 pi over 4. And what will be the general solution? Solution x equals 3 pi over 4 plus k pi, and then you can stop here. So this is how we solve the basic trig function equations. Okay, how are we going to use this information to evaluate the inverse or to define the inverse trig function? I'll talk about that in the next video.